All right, hello weirdos. So today we are going to be going over how to actually use hacks and how to actually use our RTL that we learned. And so now well, this is actually on lecture, but what I'm trying to do is actually the reason I hit it is because I want to go through the steps of the thought process of how this works. Because if you don't really understand this, then you can't really understand how to play with the registers and fill that table in exam review. Okay, so please do pay attention for this part because it's very important. Now, you can write this on your cheat sheet. Will it help? Probably. If you don't want to memorize it or if you don't want to understand it. So you could put this in. But we're not really getting tested on the RTL. We're getting tested more on how to manipulate the registers. And so you kind of need to understand one to do the other. So you can write it, but how much will it help? I don't know. You have to understand it first. Anyways, that's 1 minute gone. Right now, so for the first step, is what we want to do is move B into A. That's what this says. Is move register B into register A. Now, when we want to do that, remember when we go to this diagram, right now, we don't really control how we put everything into the IR and all that. Well, we do, but we do that at the end of the program. Remember, I said when you finish your instruction, then you replace these. So this is always at the end. Okay? This part done at the end. Okay? The IR and the CPU. Okay? Now we have the MAR. So the first thing we want to do is obviously move A and B. Now A and B are registers. They're not memory locations. It's not telling me to go to the RAM and get it. It's just telling me I have these registers already inside the CPU. I just want you to put whatever's at B in A. And so what I'm going to do is I'm going to be like A, right? I'm going to put arrow, and I'm going to put B in there. So now I moved B into A. Okay? And then so just by doing that, I've already now whatever B is, whatever's at B, I move that into A. And then what I'm going to do, obviously now that was my instruction. My instruction was just move B into A. That's done. So now what I got to do is my PC, which is the program counter, I finished the instruction. Whatever this told me to do, I finished it. So now I got to increment it, which what I'm going to put into PC, it's the old PC plus 2. Because remember how we said PC is 2 bytes. Each instruction is 2 bytes big. So we finished the job. We got to increment it to the next job. And so we do plus 2. Then, after we've done this, what we'll do is, okay. Sorry, I'm going to put it under because I can't put arrows and explain because that might be a part of the program. This is because of the syntax. And so what we're going to do is we're going to take now the IR and we're going to put into it, pay attention to this. I'm not going to put into a PC, right? PC holds the address of my next instruction. My IR holds the actual instruction. And so for me to hold the actual instruction, what I do, the syntax is M P C. Okay. Now what this does, my M, what it tells me is go to the address at PC and get me whatever instructions is there. And so what it tells me is it says go to the address. So let's say there's like move the instructions. Let's say move. What's our next instruction? Add A and B. So let's write that there. Add A, comma B. All right. Now, so what AR does, what M does is it says go to the address of the PC. Right. So PC turns into 03. This will equal add AB. Okay. That's what this equals. When you do M of the address, it gets you what the address actually is. And so when I'm putting that into the IR, I'm telling the IR, this is my instructions, which is add AB. Okay? And so that's it. I'm done. So now if I delete this so you guys can see beautiful writing, there you go. I have you put B into A. Then we increment the program for the next instruction. And then we update the next instruction. We're like, okay, this is done. This is my next instruction, which is whatever is at the new PC. All right? Now adding is, so what we're going to say is first, it says add A B. Now, if it said B, comma A, what you'll want to do is add B and A and then store that into B. But since it says A first, what you want to do is do A plus B, add them, then store that into my first one, which is A. And that's really how it is. I take A and I do, well, arrow A plus B. I add them and I put that into A. Now I finish the instruction. That's the job. I finished the job. It's done. So the next thing I do is obviously PC, increment it, get the next job, and put the next job into my IR. That's about it. Now abstraction, same exact thing, except you have a minus. And that's really it. Now we're going to delete to confirm if we're right or wrong. And see, same thing. And same thing, all you have to do is the minus there. Now, if I actually, instead of +2, I put -2, this will actually go back to this step and redo it. And so this is not, it's not like you only have to do +2. Now, +2, obviously you want to go through all the instructions. But if you want to go back to an instruction and redo it, you can technically do that. Doing PC -2, right? And so that's also fine. Okay, and so that's add, subtract, and move. All right, now we are going to be doing this, and actually let me hide it so I can explain it as I go. Oops. Let's get rid of that. And get rid of that. There you go. So here is load B. Now load is very important, and I hope you guys really pay attention to this, because manipulating registers, if you don't understand the load, it's going to get very confusing. And so now loading B. Don't get confused with B right here. Since B is not actually your B register, you're talking about an address B in the memory. All right. And so you could read it. This table, I definitely do recommend you put it in the sheet, in your cheat sheet. It's very helpful. It explains a lot of things, and it's great to look at. And so now, if you look at here, it says load, right? And so what does load mean? Load is a load value from memory, aka my RAM, at address. So B is the address. This is address. So remember how up here I had like 03 as the address? Now it's just B. That's my address. And so what this is going to be, what my B is address from or at RAM. At RAM. Alright? And so what this is telling me right here is load the memory at address. So whatever is at B. So let's say this is my RAM, right? This is my little tiny looking RAM. And right here, the address for this is B. That's the address. Inside here, I have some value. So we're going to just keep it as value. Right? I have some value. So this is telling me it's load that value from this address, which is B, into my register A. And so this is a register. Okay? And so what I'll do is, you see, in order for me, remember up here, we said in order for my CPU to do anything, and it can't access the RAM directly, we need the MAR to get us the address of the RAM so we can do something with it. And so the first thing we need is put the address into my MAR. And so my MAR, I'm going to put into it the address, which is B. That's my address, right? The address. And so I'm going to put the address first in the MAR. Now, after I've put in the MAR, what I got to do? I have my address. Can I take the value and put in A? Well, not yet, because I only have the address of the value. I don't know the value itself. How can I get the value? Well, my MAR only holds the address, but I know my MBR is the one that holds the value, right? See, memory, buffer, register, the data to be written and the data to be read. So the data you want to do anything with. So what I'm going to do is I'm going to be like MBR. Now, do I put in here, do I do M, B? Would this be considered right? The reason this would be wrong is because whenever I'm dealing with MBR, this is within the CPU. It cannot access the RAM directly. Remember, the only two things that access the RAM directly is one, the PC, which increments, your instruction count, which is it goes like, okay, this is the next address you need to do, and your MAR, which holds the address of what you want to manipulate. Okay, that's it. Nothing else can access the RAM. And so my MBR, when I do this, I'm telling it, go to address B and get me the value there, which I'm not allowed to do that because the MBR doesn't have access, only the MAR and the PC. And so what I'm going to do instead, since I've already stored B in the MAR, and remember, MAR has access to RAM, so I could do this. Then what I'm going to do, I'm going to say MAR. Oops. Now what I'm saying by this is I'm saying, hey, whatever the address that MAR, go there and get me the value. And so what this will do, this function will go to my MAR, and then it will get the address, and it will grab it from memory, and it will put it in my MBR. Now, since I have it in the MBR, which is my memory buffer register, now I can do stuff with it. I can move it around. And so what it says is move the value into A. And so what I'm going to say is, well, the value is now in the MBR. So A, I'm going to move that, right, MBR. And so what this does is it moves the MBR into A register, right? And so now A holds the value of B. And now we're done the instruction. We loaded B into A. And so what we'll do next is obviously PC increment, because we finished this instruction. We want to go to the next one. And so increment, and then IR put PC. Oops. There you go. And now if we delete this and see how right we are, as you can see, first we put the address of B into MAR, then we got whatever value is at MAR, which is the address of B, and at B is value, right? And so we put that into my memory buffer, and then from the memory buffer, I put it into my A. Then I increment it because I'm done the instruction. Now storing, you see storing, it says store value from A into memory at address, into memory at the address. So now what it's saying is go to, well, actually store, we'll use the same similar terminology, store value at A into memory, remember memory is RAM, into memory address B. Okay, so what we're trying to do, whatever value A holds, register A holds, we're going to put that into the memory address B. So in order to do this, it's basically everything reversed. Okay, now remember, if I wanna edit my B, I can't because that's in the RAM. So in order for me to access it, what are the only two things that can access it? PC, MAR. Now we know my PC just tells me this is the next instruction to do. So I can't really manipulate B through PC because that's not the job of PC. But I know MAR is there to hold my RAM, manipulate my RAM, do something to my RAM. That's what my MAR. The first thing is MAR, put my B in there. Because I can't manipulate B unless it's in the MAR. So I'm going to put it in the MAR so I can manipulate it. Now that it's in there, what do I want to manipulate? I want to get the value of A. I want to put it in B. Now, remember, here, I don't just take A and I put it in the MAR. There's no direct connection. I can go between MBR and MAR. I can go between these two steps, but I can't go from A to MAR. And so what I'm going to say is, well then, now my MBR, I'm going to put A in here, right? And so now MBR holds the value of A. Now MAR holds the address of B. MBR holds the value of A. Okay? And so I want A, the value of A, to be an address of B. Value of A is in the MBR. and the address of B in these is in the MAR. So if I want to put MBR into MAR, can't I just do MAR, MBR? Now technically, this, well, not even technically, this is purely wrong. And the reason for that is because I'm trying to take a value. So remember, MBR holds value. MAR holds address. What I'm doing here is I'm trying to put my MAR, my MBR, my value into MAR. Well, MAR holds an address, not a value. So what I'll need to do is I'm going to put it like this. Because now I'm putting a value not into MAR. I'm putting value into the address of MAR. So I'm putting MBR into the address. Now I'm not putting it into here, like instead of B. I'm not putting it, let's say MAR holds like 0x00a. I'm not replacing this address with a value. I'm not doing that. I'm going to the address, which is this. I'm putting it here. That's what I'm doing. All right. That's it. So now I stored my A into my B. And now obviously I gotta do PC, increment it. And then I gotta do my IR, which is my MPC. All right. You see now, delete all this. There you go. Actually, no, I'll keep that stuff. I'll just show this. See, so now first we put B into MAR, the address, then we put the value of A into MBR, and then we put the value into the value of the MAR. Then we increment and do the rest. All right, now we are going to be doing jump JZ, which is the checking some flags, JNZ. And I know right here it says A, right? And that's why Rapos needs to find better fucking notes, because he's mixing up A, B between registers and addresses, which is kind of retarded. Okay. Now here, this A is not a register. This is not a register. It's an address. Okay. Okay. Like I don't know why he did that. Like that is actually so stupid. It confuses the students. It doesn't make sense. Anyways, and so my operand, you see, it's an address. So if it says A is an address, because JMP takes an operand address, and therefore A has to be an address. Now it says is jump to this address, and so what jump, it means, you know how I was in memory, and I was working within here, and when I do jump, what I'm telling it is, instead of you going to the next step, go to this new address and do that instruction. Okay, and so all I gotta do is obviously change my PC. Usually we'll do PC +2, but we don't want to do this. We want to obviously usually you do PC like this, +2, but we don't want to go to +2. We don't want to go to the next instruction. We want to go to a certain instruction, which is at some address A. And so all you gotta do is replace this with A, and then your IR is the same, which is whatever is at your PC, aka the address of A. Okay. Now JZ. Now we're gonna introduce a little new terminology into the RTL, which is your JZ, which is if the 0 flag is set, jump to address. And so my A, this is the address I want to jump to. So jump to A if, I'm gonna write it big, if flag equals, obviously if the 0 flag is set. Set means if it's 1. 1 means set, 0 means not set, right? Now, if I want to write this, obviously first I have to check if the 0 flag is set. So I have to check if the flag is 1, meaning it's set, right? And so I'm gonna say if flag. Now the question is, which flag am I talking about? And so you see if I go up here, there's flag 0 greater than carry overflow. And so the flag it's asking me to use is the 0 flag, if the 0 flag, right? And so I'm going to put here Z for 0 flag. Okay. And so if it's set, so I'm going to say if the 0 flag equals 1, which means it's set, then what I want to do, so I'll write then, then, so if the flag 0, so it says here, if the 0 flag is set, jump to address. So we're going to jump to this address. So we're going to basically execute what we did here. And so what we did here is we did PC, and then we put A into it, right? We're going to jump to A, right? Now, if it's not set, else, if it's not set, then just increment my piece as per usual. Just go to the next step. Now, at the end here, outside my if statement, what I'm going to say is IR, because whether the flag is set or whether it's not set, I still have to put something into my IR. And so this goes outside my if statement because this has to be executed. Something has to go in there. All right. And so that is my JZ. And my JNZ is now we're doing the other way. So if the 0 flag is cleared, meaning it's 0, jump to address. So we're going to say here if flag. Now, is there a cleared one or are they talking about the 0? Yeah, so it's just a 0 one. If it's cleared, Z equals 0, then says then jump to address. So then we're going to say PC into A. And obviously we have our else. If that was not the case, else. If that was not the case, then PC plus 2. And here I forgot that. PC arrow. Like that, right? And then here this has to run, so it's outside my if loop. And, well, not loop, my if statement. PC, right? And that's really how you do it. It's not that hard. All you gotta be careful with. But yeah, oh, you have equal here actually, so I messed that up. It's not 1 equal, it's equal. Do remember the syntax, I'd say. Everything looks fine, so that's good. All right, and so that's how you do these. And don't forget, this is not it. There's a lot of these. I'm not sure if these are the only ones he's gonna bring, but it's the same way of doing it. Just don't forget your MAR, MBR. What do they do? How do you use them? They're very important to use. One more thing actually I'll talk about. Usually when I'm writing my code, you know how I'm writing my code like this right now? Usually what I'll want is something called a halt. Halt, what it says is usually you put it at the end of your code. So let's say you coded a bunch and the program is not done. At the end, you put halt, which means it's just that's it. The program is done. Stop executing. We don't need the CPU anymore. You're done. All right. So I hope this helped. Next thing is we're going to start doing some practice and some assembly.